Hello everyone, welcome back to my channel. So now we are going to do Leetcode bi-weekly third question. So let us first read this question, then constraint, and then finally the coding part for the same. But before that, examples as well. So here, split array into maximum number of subarrays. So you are given an array nums consisting of non-negative integers. We define the score of the subarray nums L to R such that L is less than equals to R as nums of L and nums of L plus 1 and up to nums of R where AND is the bitwise AND operation. So this is how we need to calculate score in this question. That is what they want to convey. Now consider the splitting Consider splitting the array into one or more subarrays such that following conditions are satisfied. First condition is each element of the array belongs to exactly one subarray and the sum of the score of the subarray is minimum possible. And we are required to return maximum number of subarrays in a split that satisfies the condition above. And the conditions are that exactly one element should reside in one subarray, means it shouldn't be in some other subarrays. That is, they want to say. And the score of each subarray should be the minimum possible. A subarray is contiguous part of the array. Now, so before coding this question, let us first check for the constraint. So here 10 raised to the power 5 means order of n square won't suffice here. And 10 raised to the power 6 is each number which is given. Up to that it can go. Now here, now the number which are given here. So if we first thing is that in this question, if we check that if we do AND of the whole array, if that AND is based after doing the AND of the whole array, if it is not equals to 0, then the answer would be directly equals, means we are then directly required to return 1 as the answer. But if we do AND of whole of the array, means all the elements which are there, and it is equals to 0, then surely there are multiple arrays which we could form. So because the thing is that we are required to return maximum number of subarrays. So that's why when we do that AND of whole array and it comes out to be 0, so that there is possibility that we can make more and more subarrays in this whole. So now if we do 1 and 0, right? If we do AND of the same, it will come out to be 0. So this is the minimum possible sum which we can form for this particular subarray. And if we do AND with this particular, right, then the thing would be that we can include that as well. Then again, this will be included, then again this and this. So overall, it will become 0, right? But they require maximum number of subarrays. So in that context, now we will be splitting this array. So when we do AND of 1 and 0, so it will come out to be 0. So this would be the count of our first subarray. Then this 0 we can't include, so we need to start from 2 and then next element. So 2 and 0, that will be equal to 0. Then again, we won't be including this particular, we will be starting from here. 1 and 2, that will be equals to basically, if we go ahead, then if we do the bitwise of the same, here if we see 2 raised to power 0, 2 raised to power 1, 2 raised to power 0, 2 raised to power 1, right? So here when 1 is there, so this bit would be set, this won't be set, this bit would be set, this won't be set, right? So overall it will become 0 and here it will become 0, right? So that's why this is the minimum possible for each subarray which we can go ahead with, right? And the maximum number of subarrays could be formed is 3 here. Now we go ahead with this. Then if we do AND of all of these, then this AND won't be equals to 0. So that's why in that context we will be returning directly 1 rather than splitting on the basis of that what is minimum between them. So that would be the thing. So this is the thing. Here we are required to go ahead. The first thing would be we will be checking the and for whole array which is there, and in that if it is equals to 0, then we will be then going ahead and making more subarrays. But if that is not the case, if it is greater than 0, then we will be directly returning 1 as the answer. Now, this is a thing which we are required to implement in our coding part. So, either you can pause the video and code for the same, or let us go ahead and just code the same. So here, let us start. First thing which we are required to do is we will be taking the count equals to 0. Oh, see out. Count equals to 0 and min we will be starting from our nums of 0. Min is basically the minimum, and after doing the AND operation, what is the minimum which we get? So that is min here. So now first thing is that as we are going ahead with the fact that if we do AND of whole array, what we will be getting. So for that fact only, I'm doing this. So now we will be doing AND of whole array. So now after doing this, we will be getting some value in the min, right? So there only we will check. If min is greater than 0, then we will be directly returning here as the 1. So that would be the thing. If that is not the case, then now we will be going ahead and checking. Let us take one more element here, which will be the starting part. So this would be the thing. Now, if that was not the case, so it won't return, right? So it will be going ahead and executing, right? So now we will be going ahead for forming the subarrays. So now num start size I plus plus. So here the element which is there, now we will be taking the and with the same for a nums of array, and if our element which is there it becomes equals to 0, then at that moment only we will be incrementing our count, and if we still have elements left, then in that context we will be reassigning our element to the next element which is there. That is nums of I plus 1. So this is the thing which we will be doing. Then at the end, we will be directly returning our count which is there, which we have got so far for our number of subarrays. So now let us run this code. Now we got 3. Yeah. Now, for example, test case is in 1. So now let us submit the solution. So it got accepted. Now comes the part for the time complexity and space complexity. So here the time complexity order of n. Here again the time complexity order of n. We are not using any auxiliary space. So here basically the time complexity becomes order of n and the space complexity becomes order of 1. So this was all for this particular question. If you have any doubt, you could comment that down. And if you really like the explanation and the solution, you can like, share, and subscribe to my channel, and even share with all other friends who could benefit from the same. So this was all. Thank you.